It's Mr. Z, and last time we kind of went through the warm up. We talked about some basically general review, and now we're going to go ahead and get started. So dive on in. Remember this key term, multiplicity. It's going to come up. So the idea here is that we're going to go ahead and determine the degree of each function, and we're going to go ahead and look at the highest exponent. So they're basically going through a bunch of words. You know that another name for a linear function that is not a constant function is a polynomial of degree 1. The reason is because the greatest exponent in a linear function is 1. Notice in A, there is an invisible 1. Here there's an invisible 1. The reason being is all an exponent indicates is how many to do in repeated multiplication. X to the first would be 1x. X squared would be 2 x's being multiplied. So usually we just omit it. The reason why it's not here is all x's are assumed to have the degree of 1. So A, this function f of x is a degree 1. Here, this is a degree 1 as well. And since they are degree 1, I can then say without graphing that this is going to be linear. Same idea. It's all above what was highlighted. You can go deep with your depth in linear. You know, lines can be increasing or decreasing. Increasing is caused by when the slope is a positive number. Decreasing is caused when the slope is a negative number. Here in A, the slope is assumed to be x is the same as 1x, meaning positive 1x. So A, the idea is I know that it's going to look like so. All right, moving on. Now notice in C, if I were to distribute this h, it would result in an equivalent function where x squared minus x. Notice that the highest degree is 2. This means that the shape is a quadratic. That's what we've been talking about these last few weeks. And the idea is that this quadratic is how deep do you know? Quadratics can be concave up or concave down. So in the same way that you can identify a line by sight, you can identify an equation by sight. I know that when A is a positive number, it is concave up. I know when it is concave down. And then A is a negative number. So, bonus points in my head, I can visualize this. Now D, I know that when I distribute this, the first term of j of x is going to be x squared plus some stuff, some math. I don't really need to look at it because the highest exponent is going to be 2. So I can go ahead and just do less work and see that there's 2 x's. And notice how it's degree 2. For example, in E, 1, 2, 3. This is going to be a degree 3. Y, m of x is equal to, if I distribute one of the x's into my expression, it would result in x squared minus 1x. If I were to go ahead and distribute the other x in, it would turn into x cubed minus 1x squared. I can go ahead and clean it up and just write x cubed minus x squared. Okay. Notice how it's degree 3. Did I really have to do all that? Didn't tell me the degree. Couldn't I have just counted? Okay, going back to the shape cell. This guy, the first degree is positive, so it's going to be a quadratic, and it is going to be concave up. Same idea. Degree 3, going by the definition, it is going to be a cubic. Quadratic is degree 2. That paragraph is actually quite vital. Okay. So this next part is where this new term comes in. We're going to formalize it. You probably already experienced it, but the zeros of a function are the points on the graph of the function where the function's value is 0, where the function's value is 0. For example, given the function f of x, the value of the function is 0 when x is 0. AKA, they're saying f of x is equal to x. We want to go ahead and replace the whole thing with a 0 equals x. Well, what number makes it? Well, the solution is x equals 0. Likewise, given this function, g of x equals x minus 1. I'm going to replace the whole g of x with 0. Can you solve this equation? The value is positive 1. So, multiplicity is how many times a particular number is a 0 for a given function. The 0 in each of these functions, f and g, have a multiplicity of 1. The reason being is they're said one time. It's kind of like saying x to the first. It's one time. Let's go ahead and look through it. So we're going to go ahead and look at the functions and identify the zeros. And then we need to figure out the multiplicity of each 0.